Okay, we're going to write the equations of altitude. So we're going to learn how to draw the altitude correctly and then write the equation of the line. And again, you can use point slope or slope intercept, but you're going to see that point slope is so easy to use. So let's first kind of refresh and review what an altitude is. The altitude of a triangle is it is a segment and it's going to go through a vertex. All right, so the altitude of a triangle is a segment through a vertex that is perpendicular to the side opposite of that vertex. Remember, the symbol for perpendicular is the upside down T. The altitude is also known as the height of a triangle. All right, so let's look at this example. It's going to run us through. All right, so go ahead and plot the points A, B, and C on the graph and make the triangle ABC. So 1, 3 is point A, 9, 2. There's B. And the last one, C, 7, 10. All right, and go ahead and make a triangle. All right, now we're going to find the slope of BC. So remember, if you're given a picture, just go ahead and count. So the slope, we are going to start here at B, and we're going to go up. So 1, 2, 3, 4, 5, 6, 7, up 8. All right, so we're up 8, and then we're going to go backwards 1, 2. So remember that backwards is always a negative. So there, we're always going to reduce our slope, so that's going to become negative 4 over 1. Now, C says find the slope of a line perpendicular to BC. So remember, perpendicular lines have slopes that are opposite reciprocals. So you flip the number, flip the sign. So the perpendicular slope, so remember the little m stands for slope, so this reads as the perpendicular slope is, flip the number, flip the sign, 1/4. So now, this is how you're going to construct an altitude. You're going to draw the line starting from vertex A, so here's vertex A, with the slope perpendicular to BC. So with this slope that we just found here in BC, so we're going to start at A, count out this slope. So we're at A, we're going to go up 1 and over 1, 2, 3, 4. And we're going to keep going until we extend all the way through the triangle. So again, up 1 over 1, 2, 3, 4. Now, we at least have 2 good points and we're through the triangle, so we can go ahead and we can draw our altitude. There you go. And you can go ahead there, conclude, yes, that is a 90-degree angle there. How do you know that? It's because you counted out the slopes that are opposite reciprocals. That ensures that BC is perpendicular to the altitude. Now, in E, we're going to write the equation of the altitude. So remember, point-slope form, y minus y1 is equal to the slope times x minus x1. It doesn't matter what point you choose all along this altitude. You can choose any of these good points. A, you can choose this one or this one. It doesn't matter. I'm going to go ahead and choose A because it was already given to me up here. So I just have to go y minus the y is equal to the slope of the altitude, which I found to be 1/4, x minus the x. That's it. You are finished. So if you would like to, go ahead and try this one on your own, pause it, and then come back and check and make sure you got your answer correctly. All right, so let's go ahead and run through this one. Again, if you already did it, make sure you check your answer, see if you did it correct. If not, we're going to run you through it again. So the point is here, like in example 2, it says to write the equation of the line containing the altitude to AC. So remember again, it's very important to always start off paying attention. Well, where should this generally go? Like what direction? If we're going the equation of the line containing the altitude to AC. So basically here's AC. So they want us to go to this line here. So we're going to actually have to come from B and extend down so that we go to AC. So let's find the slope of line AC. So again, we're just going to count. You don't have to count the whole entire line. You can pick two good points. So you can pick this point and this one if you want. And see, we're going to go up 1, 2, 3 and backwards 2. So the slope of AC is up 3, back 2. So perpendicular to that, it's going to be flip the number, flip the sign, it's going to be 2/3. So now we're going to draw the altitude from point B to AC. So remember again, you're starting at the vertex opposite from the side, and you're counting out the slope. So we're going to go down 2, back 1, 2, 3. Down 2, back 1, 2, 3. Remember, yes, it's a positive slope, but if we go down 2, back 3, that's still a positive slope because 2 negatives make a positive. So down 2, back 1, 2, 3. There you go. That's enough. Now we can connect all of those, and you've constructed your altitude. Now to write the equation, I'm just going to go ahead and use point B since it was given to me nice and neat there. And I'm going to say y minus the y is equal to the perpendicular slope, x minus the x. There's your equation. Now also remember, you can use any of the points on this altitude. It does not have to be this one, 15.9. Okay, I want you to add a little something extra here. I came across a problem on some worksheets and some tests and things that I need to make sure we cover. We're going to go and let's go ahead and make this a vertex here, and we'll label it E. Right at the E is the 90-degree angle. Let's say that this angle A in here was represented by the expression x plus 15, and that this angle B here is 2x plus 45. And what if I asked you here now to solve for x? Well, let's see. This is what you can look for. Now that you have an altitude drawn, you actually have 3 triangles there. You have 2 right triangles, and then you have a different triangle. If you look at right triangles, remember right triangles are your very best friends, so you're looking for them to be hidden inside of other images. So since we have a right triangle, we know that this angle is 90, which means the other 2 acute angles of every right triangle are complementary. So what you can do is take these expressions here, and we can say, all right, angle A, which is x plus 15, I know if I add it to angle B, which is 2x plus 45, that they are complementary. If you could add all 3 of them up to 180 if you wanted to do it that way as well. Here you go, combine like terms. 15, 45 is 60. Subtract 60. So 3x is 30. Divide by 3, x is 10. So basically what I want you to kind of get out of this is that you can use the altitude. So we drew altitude, which created the 90-degree angle, which then allowed me to use the right triangle and solve for missing angle measurements and solve for variables, because I know everything inside of this triangle should add up to 180. There you go. Good job. Good luck.